Good morning, my dear students. Today we'll start chapter 4, analytical chemistry. What is analytical chemistry? First of all, we have studied that all the elements, all the atoms wants to become stable. Here sodium has 281 configuration, so after losing one electron it becomes positive ion. Similarly, chlorine has 287 electronic configuration. After gaining one electron it has the configuration 288, so it gets the inert configuration. But after losing, this is positively charged, and after gaining, this chlorine is become negatively charged. We don't say it chlorine ion, but it will be chloride ion. So these two oppositely charged ions combine together, they attract each other and form a compound. This is salt. So a salt is made up of basically two parts. We have studied this is part means basic part or acid part. This basic part we call it basic radical, and this one is called acid radical, or even it is also called basic radical means cation, and this is anion. So all the metals loses electron and it becomes basic radicals or cations. So now if a salt, suppose this salt is given, we have to, but we are not knowing what is this salt. We are not knowing, we are not aware of this sample. Suppose we are given some sample and we are asked what is this compound. We have to do the study of this compound. There are many ways to confirm it that this is calcium sulfate. In details we will see it in 11-12, that is called salt analysis. You will study in the chapter of salt analysis. Here we have to deal only with we will do some reactions with alkalis. Alkalis mainly sodium hydroxide, potassium hydroxide and ammonium hydroxide, not with the fourth one, calcium hydroxide. So this analysis of the salt, reaction with the salt with this alkali is called analysis. Analysis means determination. There are two types of analysis. One is your qualitative analysis, another one is quantitative analysis. What is, first of all, what is analysis? The determination of a compound into its chemical component. Suppose if we are given a sample, what are the different components? This determination of components of a given compound of a given sample is called analysis. There are two types of analysis: qualitative analysis and quantitative analysis. In qualitative analysis, we analyze by its colors, by its different colors of precipitates form or different type of gases involves. But in quantitative analysis, we determine the composition of mixture. Suppose if we are given this calcium or calcium sulfate, the atomic mass of calcium is 40, sulfur it is 32, and oxygen is 16. 16 4 ja 64. Overall it will be 40 and 96. So we will weigh the compound. In that compound, what is the weight of calcium, what will be the weight of this ion, what will be the weight of sodium, what will be the weight of this chloride ion. This composition by mass, it is called your quantitative analysis. So qualitative analysis means identification of an unknown substance. For this, I had told you earlier, just 2 minutes before, we use three types of chemicals. They are called reagent. They are called reagent. They are mainly sodium hydroxide, potassium hydroxide, and ammonium hydroxide. So these alkali are the important laboratory reagents. When these alkalis are added to certain salt, they all are aqueous solution. So when they are added in some salts, some precipitates of characteristic color, specific color are obtained, and those metallic hydroxides are the precipitate, and by the color of the precipitate we come to know the name of the compound. Suppose if not, suppose this is the fact, if it is the salt, these all are the salts, and here is sodium hydroxide. When sodium hydroxide reacts with this alkali, with this salt, they form a precipitate. And see, they have different colors: white precipitate, green precipitate, dirty green precipitate, reddish brown precipitate. So some precipitates are formed. This is the first part. Now if we see here, color of the precipitate and its solubility in excess of alkali. Now when this calcium nitrate, sodium hydroxide are added, this is formed. We are taking only this salt for example. So in the first stage it is formed calcium hydroxide, whose precipitate's color is white precipitate, white color. Now when we add more and more sodium hydroxide, that precipitate may have three circumstances. It may dissolve, means precipitate may be soluble completely. It is possible that precipitate may dissolve partially, means they may be sparingly soluble, or the precipitate may not dissolve, means it is insoluble. There are three possibilities. We will see after a few minutes. We are knowing that salt are made up of metal and non-metal, or group of non-metals, means its salts are made up by basic radical and acid radicals. So basic radicals are metals. In the periodic table we have studied that, see, representative elements. What are representative elements? Group 1, 2, 13, 14, 15, 16 and 17. They normally form colorless ion, while those of the elements, transition elements 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they are transition elements. They also form the salt, but they form colored ions. They are generally colored. There are some examples here. Ammonium ion, the color, this is cation, ammonium ion, sodium ion, potassium ion, calcium ion. These are some specific name of the different ions. And here are copper ion, means cupric ion. What is its color? Ferrous, what is its color? So here are the names of some metals, and here are the names of some non-metals, means here are color of cations, and here are the colors of some anions. We must keep it in our mind, because in the board exam you will get such type of question. of 4 marks. This is called observatory question. In this type of question, you have to give the color of the precipitate. No other options will be there. But what is precipitate? An insoluble substance. In an insoluble substance, action of alkali on metal cation results in the formation of their hydroxide, which is insoluble. So the insoluble substance formed by a chemical reaction using the alkalis, that insoluble substance is called your precipitate. Here is now in details precipitation. And what is the precipitation? The process of formation of insoluble metallic hydroxide, insoluble substance, is called precipitation. Here, action of sodium hydroxide, when we add sodium hydroxide on certain salt, metallic salt. Once again, I would like to remind you, salt is always made up of metals and non-metal. So when the sodium hydroxide, it is also called as your caustic soda, and KOH, potassium hydroxide, is called as your caustic potash. So when sodium hydroxide solution is added drop by drop to the certain salt, the metal hydroxide form get precipitated. Here, when we add sodium hydroxide in calcium nitrate, here precipitate of calcium hydroxide is formed. Now color of the precipitate identified the metals. Earlier we have, just 2 minutes we have seen that the color of the specific metallic ion are different. So some precipitates, metallic hydroxide may dissolve completely, may dissolve sparingly, may not dissolve. So some of the metallic hydroxide dissolve in excess of sodium hydroxide to give a soluble compound. See here, calcium nitrate forms this calcium hydroxide, but when excess of sodium hydroxide is added, that precipitate is sparingly soluble. Similarly, this is ferrous sulfate and this is ferric chloride. So ferrous sulfate, when reacts, it forms green precipitate, and this is when excess of sodium hydroxide is added, it forms dirty green insoluble. Similarly, they also form ferric chloride, it forms reddish brown precipitate. On adding excess of sodium hydroxide, it forms reddish brown precipitate. Any salt of iron, mind it my dear students, will form green precipitate. Any salt of copper, after treatment, after reaction, will form pale blue precipitate. This precipitate, pale blue precipitate, is insoluble. So if we are asked in exam, if we are knowing that it forms pale blue means light blue precipitate, in some of the cases it may form dark blue precipitate. If we are missing the exact color, we can say it forms bluish precipitate. Bluish precipitate means it is, whether it is pale blue, dark blue, it will be same. But if we are knowing the exact color, dark blue, or we use ink blue, even in this year 2020, it was the same question. Here it forms ink blue precipitate. These should be kept in your mind. Similarly, here the action of ammonium hydroxide on the salt. Same thing and similar thing, when ammonium hydroxide solution is added drop-wise in the solution of metallic salt, some precipitates are formed. you can see here, here is your salt, here is ammonium hydroxide, this precipitate is formed. So some precipitate is formed which are identified their distinct colors, specific color. What are the color of the hydroxides? Now just like sodium hydroxide, some precipitates, metallic hydroxides are soluble, some are sparingly soluble, and some are totally insoluble when even in the excess of ammonium hydroxide. See here, just like sodium hydroxide, this iron salt form iron hydroxide, ferrous hydroxide, precipitate dirty green, but when excess of ammonium hydroxide is added, this remains insoluble. These are similarly, see once again here, copper sulfate. I had told you earlier that the precipitate of copper salt will be always blue, whether it may be light blue or dark blue, but will be blue only. So it forms blue precipitate, pale blue precipitate of copper hydroxide. Now it forms in the excess of pale blue precipitate. Similarly, copper hydroxide. Copper hydroxide, see here, the color of the precipitate, it will dissolve. This dissolve in excess of sodium hydroxide and form deep blue solution. Deep blue solution means inky blue solution. We can use this inky blue. Either use right dark blue or even we use word inky blue solution. Zinc, the precipitates, these are the same thing. You have to get it by heart. This forms gelatinous white precipitate which are soluble in excess of ammonium hydroxide. What is now gelatinous precipitate? We use glitter pen, blue, black, white, but when we write something on the page, some shining colors appears, that is called your gelatinous color. Similarly, lead nitrate will form white precipitate, which is, this precipitate is insoluble. When it, sorry Babu, precipitate means insoluble, but when it is added in excess of sodium hydroxide, it remains chalky white precipitate or curdy white precipitate. It is insoluble. This you have to get it by heart. You will get such type of questions, observatory questions every year. Now certain metals, not all the metals, certain metals, you see, mind it, zinc, aluminium and lead, when they react with alkali, certain metals like zinc, aluminium and lead react with concentrated means hot, freshly prepared alkalis, they form soluble salts. See here, when zinc react with sodium hydroxide, it forms sodium zincate, color is colorless. Likewise, this potassium hydroxide, it forms potassium zincate. Similarly, here aluminium zincate, sodium, or it is also called sodium meta-aluminate. Like zincate, it forms sodium or potassium aluminate. With lead, it forms sodium. Just like zincate and aluminate, it forms plumbite, sodium plumbite or potassium plumbite. One word will come here, amphoteric substance. Normally what happens, the acid reacts with base, it forms salt and water. You will never come to know that base reacts with base and form salt plus water. You will never come to know about this. Similarly, acid reacts with acid, forms salt plus water. You will never have this concept. It forms salt. Acid reacts with acid, undoubtedly. But what I said, it will form salt and water. You will never have this chance. But there are certain substances like zinc, aluminium, lead, its oxide, and its hydroxide. Zinc oxide and zinc hydroxide. Similarly, aluminium oxide and aluminium hydroxide, lead oxide and lead hydroxide. See, only zinc, aluminium and lead, its oxide, they are basic, they are bases. So this is base, this is base, this is base, these three are also base. So these six are bases. We know that acid reacts with base, but these six, only these six, there are no seventh any other base. These six bases reacts with acid as well as base and form salt and water only, no third product, only salt and water. So the compound which reacts with acid as well as base and form salt and water, they are called amphoteric substances. Only six are there, Babu. The oxides of most of the metals are basic in nature. They dissolve in water, forming the hydroxide. See, sodium hydroxide forms sodium oxide forms sodium hydroxide. Sodium oxide reacts here, it forms this salt. So sodium hydroxide plus HCl, this is base, this is acid, it forms salt and water. So only acid and base react to form salt and water, but there are a few metallic oxide and hydroxide. Few metallic oxides, only 3 metallic oxides and only 3 metallic hydroxides. So only few metallic means only 3 metallic oxides and 3 metallic hydroxide exhibit the dual characteristics. Dual character means dual characteristics. What is this dual characteristic? Those they show acidic as well as basic characteristics, means they can react with acid as well as base. So these six are said to be amphoteric in nature. So now what is amphoteric substance? The substance which reacts with acid as well as base. So my dear students, if you can observe here, zinc oxide, it is a base. Zinc hydroxide, it is a base. It reacts both reacts with these two only, reacts with acid, it is forming zinc chloride and water, salt and water. Now in these two reactions, if you see, this is base, this is base, zinc hydroxide is base, sodium hydroxide is base. So these two reacts, these two bases reacts, it also form salt and water. Similarly, similar conditions are here. These are the bases, they react with another bases, they form salt and water. Here is aluminium oxides or hydroxides. They also react with the alkalis like lead oxide or hydroxide. They are also forming salt and water. So my dear students, even we can ask in the exam, most positively as far as I remember, in 2016 it was asked, write the name of two amphoteric substances. It was the question was of 2 marks. So we will write any two. It is not necessary that we will write, if we are asked to write two names, then zinc oxide or zinc hydroxide. No, we can write zinc oxide and lead hydroxide. Sorry, Babu. It will be PbOH. Sorry, it will be PbOH2. Any two names we are supposed to give. So this is for today. We will meet in the next class. We will start the new chapter. Thank you. Wish you all the best. If you have any problem, once again I would like to remind you that we are suffering from this contagious coronavirus. So school is not able to run. So we are also feeling that you may have some problems on online classes, but for the clearing the doubts, you are always requested to make a touch with your concerned teacher. So once again, wish you all the best. Thank you. Bye bye.